Today I'm going to teach you the apparent weight gain and weight loss, and I'm going to do this scenario first, a crouching, and then I'm going to show you how that happens when you take elevator. So from crouching to elevator. So let's do it with crouching. Apparent weight weight gain and weight loss. Weight gain or loss. So apparent weight gain or weight loss, that's our topic, and the case study is crouching. So you're gonna be doing crouching up and crouching down. So what do you need? You need a scale. So here's what you need. You need a scale. All right, and being still on a scale. And let's say you are 100 kilograms. So your mass is 100 kilograms. So if you do stand up on a scale, what do you see on a scale? And what the scale would read? Scale would read 100 kilogram this time, because scale will read 100 kilogram because no apparent weight loss and weight loss is 0 kilogram, and apparent weight gain is also 0 kilogram, because acceleration is 0, and net force is 0. All right. So that's the reason you won't feel any difference. So you feel normal. All right. So that takes us to scenario 2. Scenario 2, you're going to be crouching up. Well, let's do crouching down, because you have to crouch down before you crouch up. So crouching down. So if you do crouching down, then you need some negative acceleration. If you crouch down, you need some negative acceleration, because your knees crouching down. So to do the crouching down, in the other case, we're going to draw the free body diagram. So in this case, free body diagram would be FG and Fn. Gravitational force is equivalent magnitude with the normal force. In this case, the gravitational force would be 1000 Newton. What are we going to do? Today we're going to use acceleration due to gravity is 10. Acceleration due to gravity is 10 meter per second squared. So the force due to gravity is 1000 Newton, and normal force is 1000 Newton. That's why there is no net force and there is no acceleration. Okay, if there is no net force, there is no acceleration, then the scale will read exactly the true weight. So true weight in kilogram is 100 kilogram. That's what the scale is reading. Now we're going to do the free body diagram. Why the normal force is smaller right now? Because there is an acceleration down. Why there is an acceleration down? Because in order to crouch down, you have to have a negative acceleration. Otherwise, you are not crouching down. All right. Negative acceleration due to net force, which is to the downward direction. What is the consequence? The consequence, you feel lighter. What do you mean you feel lighter? You feel lighter due to apparent weight loss. How much apparent weight loss? Well, let's see how much apparent weight loss. So Newton's second law tells us we have to use Newton's second law, because there is a net force. When there is a net force, don't use Newton's first law, use Newton's second law. So you're going to use Newton's second law. So net force, because net force is not 0. So when net force is not 0, then you have to use Newton's second law. So now Fn, and we have Fg. So let's write Fn minus Fg is equal to negative ma. Why negative ma? Because acceleration is downward direction. Normal force is So what is the normal force? Normal force is equal to mg minus ma. All right. So Fn is equal to mg minus a. So Fn is equal to m is 100 kilogram. 100 kilogram, g is 10 minus acceleration, let's say 2. All right, so Fn is equal to 100 times 8. So Fn is 800 Newton. So then mass is now 80 kilogram. So do you see the apparent weight loss? Yeah, you do see apparent weight loss because the true weight is 100 kilogram. True weight is 100 kilogram. You see, true weight is how much? True weight is 100 kilogram. So now the person is feel much lighter because the true weight is 100 kilogram, and apparent weight in mass is 80 kilogram. Apparent weight in kilogram is 80 kilogram. So there is a apparent weight loss of 20 kilogram. So 20 kilogram. So the person will feel 20 kilogram lighter. So the person will feel 20 kilogram lighter. Why? Is because there is an acceleration downward. So as a consequence of crouching down. So this is the second scenario. Now I'm going to do the third scenario. Scenario number 3. So scenario number 3, just reminding you what is scenario number 3 would be scenario number 3, crouching up. Crouching up. So when you do crouching up, what is happening? Well, when you do crouch up, this is what happening. So the consequence is, in order to crouching up, there has to be some acceleration. So acceleration is upward direction. When acceleration is upward direction, acceleration comes from net force. So net force is also upward direction. And what is the consequence? The consequence is you feel heavier. You feel heavier. And why you feel heavier is because apparent weight gain. So everything is connected. Apparent weight gain. Apparent weight gain. So you feel heavier is because apparent weight. In the free body diagram, as I said, that the weight cannot be different. So weight is the same, which is 1000 Newton. 1000 Newton. But normal force is bigger. Normal force is bigger in this case. Let me exaggerate a little bit so that I make the point clear. So weight remains same. Oops, I did not make the point clear. I said the weight would be same in magnitude no matter what you do. But normal force would be the difference. So let's make normal force so big that you understand what I am trying to say. In this case, the normal force is higher is because there is an acceleration upward direction and there is a net force upward direction. What does that mean? That means the person is heavier. What does that mean? The mean is person is experiencing weight gain. What does that mean? That means Fn is equal to mg plus a. Let's do that. So Fn, we're going to have to use Newton's second law. Why we have to use second law? Because the net force is not zero. When net force is not zero, we are using Newton's second law. F equal to ma. In this case, ma is positive. Ma is because acceleration is upward direction. And F, we have to add all the forces acting at the y direction. What are all the forces acting at the y direction? I see Fn and I see Fg. So that Fn is equal to mg plus ma. What does that mean? That means that the acceleration due to gravity add up with the acceleration, man-made acceleration. What does that mean? That means the person feel heavier. How much heavier the person feel? The person feel so much heavier. The person feel the person usually 1000 Newton. The person is 1200 Newton. That means the scale will read 120 kilogram. So the person is 20 kilogram heavier. All right, so the person, there is a apparent weight gain of 20 kilogram. Person feel heavier. Now scenario that takes us scenario number 4. Scenario number 4, when person crouching up, that takes him in the middle of the air. So the person in this time is in the middle of the air, all right, at the maximum height. Here is the ground. All right, now first thing we're gonna do the free body diagram. So if we do the free body diagram, what do you see? We see the weight is same. Weight is same means weight vector has to be equal in magnitude with all other three. The first weight vector was 1000 Newton. Second weight vector was 1000. If you that's so long ago, so I have to remind you. The first weight vector is, as you see that the first weight vector is 1000 Newton. 1000 Newton. The first weight vector is 1000 Newton when the person was standing still on a scale with acceleration is 0 and net force is 0. Second weight vector is also 1000 Newton. Did I write 100 Newton? That was by mistake. I'm glad that I'm revisiting it. So 1000 Newton. What does that mean? That means even if the person accelerating down, the weight does not changes. Weight does not changes. The third scenario, when person crouching up, accelerating up, that does not affect the weight. Weight is still 1000 Newton. Now, scenario number 4, when the person is in the middle of the air at the maximum height, the weight vector would be same. That means the weight is still 1000 Newton. However, there is no normal force. In this case, the normal force is 0. So scenario number 1, the normal force was equal in magnitude, opposite in direction. That means normal force was 1000 Newton. As you see, normal force is 1000 Newton. Second scenario, when there was a negative acceleration, there was a small normal force. There was a small normal force. A smaller normal force, as you see. The third scenario, there was a bigger normal force. There was a bigger normal force, as you see. Now the scenario 4th, the normal force is 0. Scenario 4, the normal force is 0. Now let's see what is the acceleration. Acceleration is in this case acceleration is 9.8 meter per second squared. What does that mean? That means person is moving down with 9.8 meter per second every second. So the person, what is the consequence? The consequence, the person feel weightless. Weightless. How much weightless? If you put a scale on the underneath a person feet, what the scale will read? The scale will read 0 kilogram. So the person will feel the apparent weight loss is, what is the apparent weight loss? Apparent weight loss is 100 kilogram. So summarize everything I did. Before I wanted to teach you the physics of elevator, I wanted to teach you what's going on when you crouching down, crouching up, and make a vertical jump. You can divide this in 4 important scenarios. Scenario number 1, and you're standing still on a scale, and that apparent weight loss or weight gain would be 0 because acceleration is 0 and net force is 0. Scenario number 2, you crouching down, you need some negative acceleration, comes from the net force, negative net force, and that will the consequence would be you feel weightless because apparent weight loss of 20 kilograms. Scenario number 3, you jumping up because there is an acceleration upward, comes from some net force acting at the north direction. You would feel heavier because there is an apparent weight gain of 20 kilogram. That takes us scenario number 4. When you're jumping up, at some point you are at the maximum height. That maximum height, the normal force is 0. So what would be the consequence? The consequence, you feel weightless. Why you feel weightless? Because apparent weight loss of 100 kilogram. So if you have a scale underneath of your feet, what the scale would be reading? Scale would be reading 0 kilogram. Thank you.